Good morning, good evening. Today is quite special because from the schedule, we have a speaker, two speakers, including Prakash. He will talk about the overviews of air quality sensor network data across AQC. And then, yes, okay. And then Dr. Ron gonna talk about the AQC, air quality modeling and discussion support. And after that, we're gonna break out the room in each country. So right now, I think we have 4 rooms, right? Okay, 4 rooms: English, Thai, Vietnam, and Laos. And we will discuss in each country. And after that, we're gonna come back in the main room again, okay? During breakout room, participant can join the room by your own self. And after that, you can leave the breakout room by your own self as well.
Okay, I think now the time is for our schedule already. The first person, please welcome Dr. Prakash to give us the overview of air quality sensor network data across air quality monitoring in Southeast Asia. Please welcome.
Thank you very much. Good morning, everyone. So let me share my screen here. Okay, well, good morning, everyone. So the past 2 days, we have, looked at the network in general, talked about what the regulatory framework currently is, the current air quality monitoring network. And yesterday we went into just an introduction of this network and also talked about the regional challenges. So today, as they mentioned, we are going to have a brainstorming discussion. So this presentation is supposed to kind of provide some preliminary insights into the data that's been collected so far. So this is some fresh analysis that I did just over the past day. Obviously, I think I'll look for assistance from my collaborators in kind of any interpretation related to the specific site in that region. So let's get into it. So as you may have noted yesterday, the sensor network consists of both purple air and dust buoy sensors. We plan to deploy about 100 purple air sensors and 15 dust buoy sensors on this project, as well as leverage 600 dust buoy sensors that's already been deployed in Thailand by Chiang Mai University. As of now, the purple air sensors, we have deployed about 42 sensors with the distribution shown there, and about 5 dust buoy sensors in Thailand on this specific project. Before I get into kind of what the data shows, I want to talk just a little bit about the sensor itself. The purple air sensor is an optical sensor, and what I mean by that is there's a light source inside the sensor, and there's a small pump, a fan that pulls in sample, and the particles scatter the light, and so the sensor then estimates the PM2.5 or the particle loading based on the amount of light that's scattered. The sensor requires continuous wireless internet access and electricity for continuous operation. So if either one of it is not there, then we will experience the data loss. The data gets transmitted in real time to the purple air server and is available on the open domain. Now each instrument, so this the bottom left is a figure of how, an image of how that sensor looks, but each instrument actually has 2 sensors. So I have labeled it as A and B here. So these are 2 identical sensors, and the purpose is to kind of provide like an internal QC check. And so what I'm going to do now is kind of just show you some analysis of what I've looked at in terms of the data. How does the data look? What type of temporal patterns do we see? What type of spatial patterns we see? And just to kind of give some ideas as to how like in what all ways we can look at the data. So initially, let's just take a look at the QC checks, the quality checks. Like I mentioned, each unit has A and B, and those are identical sensors. And so what I show here is the correlation between A and B, between the two sensors within each unit. And this is across all the sensors deployed in each country. And so basically, you see that it's pretty much a straight line, and the R value, correlation value, is more than 0.997. It puts the same case like across all three countries. Obviously, the number of sensors differ, right? So Thailand has about 18 sensors deployed, Laos 5 sensors, and Vietnam has 19 sensors deployed. But in any case, you're seeing a good correlation between the two sensors. And that is an internal quality check to just make sure that the sensor is operating properly. And the box plot on the right shows the distribution of the correlation across the different sensors, right? So this one, we can't see how each sensor performs. And so this is kind of showing a distribution across the sensors just to see how big the variability is. And again, you can see the scale here, it starts at 0.992 or 993. And pretty much most of the data is above 0.997, right? So the 25th percentile, the whisker here for Laos is 0.997. So if we just look at the 25th percentile and above, it's actually 0.998 or better. So there's just except for a few outliers here, right? So basically it says that the sensors are operating as expected. Both the sensors are reading pretty similar values. And when we look at the mean difference between the A and B channel, so we refer to those as A and B channel, right? Within each unit, you have this A and B. So we refer to that as A and B channel. So when we look at the difference between the two, and what I'm showing here is the percent difference. Typically, we would like for it to be less than 20%. That is kind of the rule of thumb that Purple Air uses. And I think that's probably expected for low-cost sensors. And for the data that's been collected so far, which is from August of last year, from 2021 up till now. So the data, I pulled it at, I think, until mid of April. So we are seeing the difference is typically less than 10%. And the concentration ranges, it ranged anywhere from 3 to 5 micrograms per cubic meter for the low concentration time period to as high as 80 in Thailand and maybe even 140 micrograms per cubic meter in Laos. So basically, in Laos and Vietnam. So basically, even at the low concentration ranges, if you look at it, you would expect the higher percentage ranges, and that's probably where the higher percentage ranges come from. But in any case, the percentage distribution is within 10%, and the 25th percentile or the interquartile range, if you look at it, is typically within plus or minus 5 units. But another aspect of the sensor performance is obviously how it compares to the regulatory monitor, right? That is what we are ultimately interested in. If we want to use the sensor data on a quantitative basis, we need to correct it to a reference method. And so that's Dr. Seth presented this yesterday, and he showed, and this is just a reproduction of that slide. Basically, it shows that there's excellent correlation between the BAM, that is the reference instrument, and the Purple Air sensor with an R-squared value of 0.94. And all the metrics here were actually good. And I think they note that the bias and error were slightly over target value. And this is uncorrected value, right? So this is just a relationship between the raw Purple Air data against the reference monitor data. And what we found is I have another project where we deployed close to 100 sensors, 90 sensors or so in India. And we co-located about 50 sensors next to BAM. And we went through this process of bias correction. And we developed both a linear model as well as a random forest technique, a machine learning technique. And what we found is that after correction, you can reduce the error. Now, be it whether it's a root mean square error or the mean absolute error, you can reduce it by nearly 30 to 50% and sometimes even slightly higher. So what it basically says is after bias correction, then there is this potential to bring the sensor data back in line with the recommendation that US EPA has listed in their sensor guide. Obviously, we have not done that yet for AQC network data, but that is one of the next steps that we are going to be working on. But basically from the data, both in literature as well as from my own experience in other regions in Asia, I think it's pretty certain that we should be able to achieve a pretty good, we should be able to reduce the error in the sensor data. Now, we have been able to collocate only in Thailand, and we would probably need to do a similar collocation in Laos and Vietnam as well, if we want to improve the estimates to be very specific to those regions, because the calibration is really region specific. Granted, there is probably some similarity in the source influence between Thailand and maybe Laos, so perhaps this calibration might still work. But if we can do a calibration in Laos and Vietnam, that would actually be much better. And we would really love to collaborate with the agencies in those countries. So now let's just look at the temporal patterns on what we see in terms of the data. So what I'm showing here is now a series of slides with just plots that shows for each country. This is the monthly average. I just wanted to kind of show how the trend is. And this is for all the sensors that are deployed in each country. And basically the x-axis is the month. So this is July, it starts from June and goes all the way up till April of this year. And I think this is as expected. You would see that the concentration is lower during this June, July, August, September timeframe, and then increases, reaching maximum, at least as of now, until about April. And you see here, there are some definitely data gaps here. And I think that's related to either the loss of power or internet access. And until we were able to detect it and inform them, obviously the census did not collect data. The same type of graphs here for Laos. So they start again, same type of pattern, but the concentration ranges are different. So here in Thailand, you can see the scale went up to about 80. In Laos, it went up to 150. And so depending on the sensor, some of the concentrations were really high. And it's actually kind of just in April, like March, April timeframe is when the concentration started shooting up to that level. And likewise in Vietnam, the slightly different pattern, they are seeing peak much earlier in December timeframe, and it actually concentrations actually started decreasing after that. While in Laos and Vietnam, the peak is just now just around April timeframe. So this is just a monthly average. We could look at something similar on an hourly basis, but that will be a little bit more crowded for this, when we're looking at the entire 7-8 months. So that's why I just showed a monthly average here. Now, when we look at the diurnal profile, of course, you could also look at it, how it does by hour of the day and averaging it across the entire time period. And you can see, I think I just want to kind of show like a high picture here, that the diurnal profile varies depending on the location. Some locations have this really strong diurnal pattern, while others really exhibit pretty much like a flat and a slight dip during the daytime when the inversion layer expands. And for Laos, pretty much all the locations, it's only deployed at 5 locations, pretty much all locations showed a very strong diurnal profile. Vietnam, it's similar to Thailand, where some sites show strong diurnal profile while others don't. So that's on the temporal observation. So basically, I think I've covered all this. In sake of time, I'm going to move forward. But basically, yes, the peaks are at different time periods depending on the region. And Laos and Vietnam experience higher concentrations than Thailand. And obviously, I think one caveat is the data is available just less than a year, right? So I don't think we can come to any large conclusions. We will need to have data for a much longer time period. But this is the trend that we are seeing based on the data just for the past several months that we have collected. Now let's look at the spatial pattern. And what I do here is I took the monthly average and then I just showed on the map just to give you an idea of how it varies spatially. Now it's a lot of slides. I'm just going to go through quickly. The main object, instead of doing an animation, I had individual images. So I just want to show how it translates, how it kind of, changes over time. And so you'll kind of see this pattern where Vietnam peaks in December and then Laos and Thailand starting to peak in March, April timeframe. Okay. So now this is September. Obviously, so this is Thailand, Laos, and Vietnam. There wasn't any sensor deployed at that time. They started just after the COVID cases came down. So now you start seeing sensors in Thailand. I'm sorry, Vietnam. Okay, so I'm going to go through this. That's September, October, and you can also keep a note on this concentration range. It's the same color used across all the images, maps, but if that specific concentration range wasn't there, it wouldn't show up. But basically, you would see it actually going up. So there's November, December. So basically, it's the November, December timeframe when Vietnam peaks, and then it starts coming down, and then you start the color getting a little bit darker in Thailand and Laos, right? And so when you reach kind of March and April timeframe, then you kind of see the concentrations really high. So that's kind of just tells you how the spatial variation is. Now, finally, I just want to conclude with this. So what I've shown so far is kind of at a really high level, average basis. So you're not going to be able to see this variation in real time. So this is a snapshot of the data just about an hour before this event. So it's like maybe 8 a.m. your time or maybe 7 a.m. your time. So a couple of hours before this event started. And one of the ways to make sure that the sensor is working well or not is if you're going to be seeing such drastic differences, then we will need to investigate that further to see whether that's a real or whether that is some other pattern. Now, for this specific case, okay, so this time series here, it shows both of these sensors, the ones that are marked 127 and 168. That is the concentration range and colored as per the US AQI. So obviously the color code will be different for the regions if you're going to be using country-specific color code, but this is the default that Purple Air map shows. But to confirm this one, what I did is I looked up the satellite data, and what we are seeing here is, so this the several layers, the one here that shows in grayish color, that's the smoke, and the white is the clouds. So there is definitely some smoke from the biomass burning. I did not show the fires here, but you can also overlay that. And then the yellow and red is the aerosol index, which is an estimate of the loading in the atmosphere as derived from the optical depth and also the height at which the aerosols are concentrated. So if I'm going to go back and forth, and I had here Chiang Rai for reference to kind of see, right? So the sensor was right here, and the other sensor in Laos was just in the eastern part of Laos, so right here. And so I'm going to go back and right, so that's where the sensor is and this sensor is. So you can kind of see that it is consistent with the smoke plume and the high aerosol optical depth that is observed by the satellite for this region around the same time period. So again, so that's just an example of looking at it, on a real-time basis. So I'll just stop there. Basically, I think they want to conclude that sensors offer valuable data. Data completeness will be impacted if there is loss of power or Wi-Fi. Sensors without any bias correction, you can look at it on a relative basis, whether it increases or decreases, and on a qualitative basis. But with bias correction, given the high correlation with the reference monitor, then there is this potential, for using it for quantitative applications. So I'll stop there. Thank you.
Okay, thank you, Prakash. It's very, very nice data and very good data for support us and all of 3 countries. So now any question from the audience to have to give to the Prakash? So I have one question, Prakash. The slide from, I think, before the end of your slide, they have the map, worldwide map. It's very useful. Why they have some data missing from Thailand?
So that is what they call as the swath. So the satellites, when they pass over a region, right? So that's just kind of the edge of that swath, and it's not going to be, so there'll be some missing, and you can overlay different satellite data to actually fill that gap. But that's why this that black gap that's there in that region.
So the map is every day have like this, or only some day?
That is correct. It is every day. So the satellite that is used for this one, it is on a daily basis, and it's one value per day. Right. And if you're using the modus, it will be actually 2, one in the morning and the other in the evening.
Okay, thank you.
Yeah, I saw on the map of the sensor location in the south of Vietnam. I saw in the center of Vietnam. I saw 2 locations. It's not like a turn on. Is that for the whole period, or just? I understand that it should have some happen of disconnected, but we control on the sensor daily.
Yeah, so that's a question I wanted to talk to you as well as Hang. So I was not able to identify those 2 sensors. So I think we are missing actually 2 or 4 sensors for which data is not seen on the purple air. So let's talk offline. I'm thinking maybe it might be registered as a private instead of being public. So if that difference is there, then the data wouldn't show up on the website. So that's one thing I wanted to check with you.
Yes, you should check it, because I think that the data should be remain somewhere, but it not appear on the
right. Right. Yeah.
Okay. Yes. Thank you.
Okay.
So I see a question from Evan Bing. Evan, thanks for joining. Which of the correction factors available on the Purple Air website best matches the co-location data so far? That's a good question. We have not tried it yet. I think so. This much of everything that I showed here is actually kind of hot off the press. So that's definitely something that we can, we want to try. I think the first thing that I want to try is maybe using the EPA's correction factor that's published, and that was also presented by Allison yesterday. So I'm going to be checking that, but yeah, I think that's something that that be one of our next steps to see if any of the existing correction factors would work.
So any question from the audience? So if not, we can move to next schedule from Naris. Will give us air quality modeling and decision support from Dr. Ron. Please welcome Dr. Ron.
Hey, good morning, everyone. This morning, I'll talk about the air quality modeling that we've started. We started some operational, quasi-operational, or the experimental system. This is together with, of course, Vanessa, who's been working on improving the emission inventories. And of course, our research assistant, Sharin Hassan Brand, who's been also our PhD student, who's been, I think doing most of the optimization and sensitivity analysis. So this is our current experimental forecasting system. Well, it's for Indochina and Southeast Asia. So we've got, so we simulate two domains for Indochina as well as Southeast Asia. For Indochina, we use like 9 by 9 kilometer, and then for Southeast Asia, like a 27 by 27 kilometer. So this is our current website. So my apologies. So we'll try to have a better domain next time. So if you go to the website, so the first page you'll see will be like some like headline news. So like I advertised our workshop here and some current events that's happening in Indochina and Southeast Asia, and with a little bit also of some like analysis as well. And for this system, so I'm envisioning it to be more like of a community base. So like you can, so there's some small chat box. So if you have some comments, if you see something that's not correct, or if you want your data to be part of the validation, yeah, so just please ring us up or chat us there on the chat box there. So this atmospheric or air quality forecasting system that we've started is based on this paper that was just recently submitted by our research assistant to Atmospheric Research Journal, Sherin, who did the sensitivity analysis to the different model chemical schemes and also the effects on the regional meteorology. But we focused in this paper on northern Thailand. So in this paper, so we used a WRF-Chem at 9 by 9 kilometer resolution. And then we looked at two different aerosol schemes that are commonly used in air quality modeling, which is called the go-kart and the mosaic scheme. So go-kart is a bulk aerosol scheme because it's a bulk aerosol scheme, so it's computationally efficient. So this is what we use now for the forecast. However, it has some limitations, like it doesn't have size information for most of the chemical components of PM2.5, and it doesn't have secondary organic aerosols. While Mosaic has a more complex scheme, however, it's more computationally expensive. So it's also an issue when you want to do some forecasting as well. So we need to like balance between computational efficiency as well as accuracy in this case. So that's what the main goal of this paper. So we look at the two schemes and yeah, which one turned out, is there a significant difference between using the two schemes or not? Okay. So in this study, so our domain is Indochina. We focused in Thailand, and so we used the pollution control department stations, reference stations across Thailand. So this is this black stars on the figure. And so we divided the country into its regions. So we use like regional averages instead of like station-wise comparisons with the model. So here you see the blue is from the pollution control department observations of PM2.5. Green is using the WRF model using the mosaic aerosol scheme, and red is the go-kart scheme. So not much difference when you look at the PM2.5 in the north. So this is for the northern part. And this is for the northeastern part here. But of course, the northeastern part only have few pollution control department stations. So we're a little bit underestimating for the mosaic and overestimating for go-kart here. And then for central, including Bangkok, so this is how it looks like, the time series and regional average. But yeah, so again, most of the stations are concentrated over Bangkok here. And then on the eastern region, okay, over here, and then on the southern region where our model is a bit like underestimated. So the study period we chose actually for this study is between March 15 and April 15, 2019. And looking at the model performance for each region, so actually the model is, I think, moderately doing well, except for the southern part. So probably we're still missing some of our emissions, especially the biogenic emissions there. And then we also compared over Chiang Mai City only, because that's only where we had the measurements during this period for the different chemical components of PM2.5, and see if there is some discrepancies. So for the total PM 2.5, it seemed the model is, I think, doing fairly well. So it's getting the variations quite okay. What we are a bit underestimate for both WRF mosaic and WRF go-kart. And then looking at, let's say, the chemical components like black carbon, I think black carbon, again, I think the model is doing fairly well as well. A little bit underestimate at some of the episodes here. And then for organic carbon, I think the model, especially go-kart, is actually doing quite well, even though it doesn't include the secondary organic aerosols. However, when we go to sulfate and to nitrate, so this is for sulfate, for example, so we greatly underestimate the sulfate from the model. Okay, but I think the mosaic, I think it's getting a bit good in terms of the variation there. And this is for the nitrate, where go-kart really it's really underestimated here. And mosaic, I think, also underestimated, but I think it gets at least these variations or these temporal variations. So yeah, so sulfate nitrates, so we're not getting them correctly, probably due to the maybe not updated emission inventories for anthropogenic as well. And then we tried to compare during this time period between a low and high air pollution days relative to northern Thailand. So we want to see, let's say, the effect of meteorology on the air pollution. So for the low air pollution day and high air pollution day, so we just compared the different anthropogenic emissions. Of course, so since we're using like monthly anthropogenic emissions, so it's not much difference between a low and high air pollution day. For the biomass burning emissions, so we used the near real time fire emissions from NCAR during the low air pollution day. So this was in March 21, 2019. So of course there are a bit fewer fire emissions, okay, especially over Myanmar and Laos there. And during the high air pollution day, which was in March 24, 2019, so we see more fire emissions, particularly over Laos here. So when we look at the PM 2.5 concentration, so we have the emissions plus the meteorology. So you see, like during a low air pollution day relative to northern Thailand here, so most of the winds are blowing towards the east, okay, in this direction, okay. And the winds are a bit stronger during this time. And during a high air pollution day, so the winds, as you can see, is a bit weaker over northern Thailand. And so yeah, so that doesn't disperse much of our air pollutants over this region. So we also look at like the effect of the mixing height or the PBL height on PM concentration. So this is a paper we published 3 years ago, using our LiDAR measurements. So we can see when you look at the daily variations or diurnal variations, so the PBL height greatly controls or modulates this diurnal variation. So if you have a low PBL height given by this blue line, so you have relatively higher concentration. So usually the situation would look something like this. And if you have a higher PBL height, of course, you have more volume for the pollutants to disperse. So you have this situation here. So you have relatively lower PM 2.5 and PM 10 concentrations. So the PBL height is quite important. So we need to model the right to get the diurnal variation or concentrations also correct. So here you see the effect of the PBL height on PM concentrations. However, we found out that the PM also has an effect on the mixing height or PBL height, or it has some feedback onto the meteorology as well. And we noticed this when we deployed our LiDAR measurements over Phang, when you have like really high PM concentrations or given by this high extinction coefficient. So sometimes we lose our diurnal variation altogether in the PBL. So given by this white line here. So like here for March 30, 2019, which was really high concentrations of PM 2.5 over this area. So almost our PBL height diurnal variation is non-existent there. So yeah, so the PBL height, we need to get that correct to get also the modeled PM concentrations correct. So with that, let's look at this year's haze situation, particularly in Chiang Mai City from December to April. So this is using the forecasting system that we developed. So this is for December. So the red dots, so these are the PM 2.5 observations from Pollution Control Department. And the red line is the modeled PM 2.5. So the blue line is the forecasted PBL height or mixing height. And the blue dotted line is the observations using our LiDAR over Chiang Mai City. So actually over during December, this is what I noticed during December, January, and February, I think we're doing quite well in terms of simulating the PBL height. So we're also getting the, I think the PM 2.5 concentrations fairly well. Okay, so this is during December. So if you get the observations may be like averaging over 20, 25 already. So this is in December. And then January, so there are like some days where our PBL height's a bit off, so a bit overestimated, for example, here. And I think this is also where I think some of our, I think, well, actually in January, so the concentrations seemed, the PM 2.5 concentration seemed to be a bit lower, maybe averaging around 20 compared to December. Okay, but the forecast still doing quite okay. And this is for February. So February, when the aerosols or the PM 2.5 starts to increase, I think going up to 30 micrograms per cubic meter here. So we also start seeing that our PBL height's not the forecasted PBL height is we get more situations where it's overestimated here. So that's given by the solid blue line there. Okay, so we're in terms of the simulated PM 2.5, we're a bit underestimating. And towards the end of February, so you can see the PM 2.5 starting to increase. So we're still getting the variations quite okay. So when observations increase, the simulations of forecasts also increase here. But in March, we totally didn't do well for March and April. So this is for March and April. So I think because since we're getting more PM 2.5, more aerosols into the atmosphere, and since from our previous study, so we are not able to capture, for example, sulfates and nitrates, and also probably due to not updated emission inventories, both biogenic and anthropogenic, which I think Vanessa is working hard a lot on updating our emission inventories, both biogenic and anthropogenic as well, at least for northern Thailand. So yeah, so most of the days during March and April, we overestimate our PBL height, and that makes our PM 2.5 forecast underestimate here in most of the days. So we're still getting some of the variations at some days, but generally, we're not able to capture much these observations during March and April. So I think because we're unable to capture, let's say, the sulfates and nitrates, so that will probably translate or propagate into inaccurate aerosol radiation and PBL, and of course cloud and rainfall interaction. So we'll so these errors will probably propagate in this aerosol radiation interactions, which is, I think, quite significant factor during these months. And then we also compared for this year 2 days when you have the low air pollution around, I think, just maybe last week. Okay, I think this were also after some rains. So we also looked at the high air pollution day, which is like before the Thai New Year holidays. So the background actually over during this high air pollution day was also quite high, and then a lot of biomass burning also going around here in this area. And then this is for the current situation. So this is like the 3-day forecast for PM 2.5. This is initialized April 26, and this is initialized April 27. So a lot of things still, lots of emissions still happening over Laos and over this area as well. Okay, but so the winds are moving, I think, more towards the east. Okay, so in northern Thailand, so we're still getting a bit higher, like around 50-40 micrograms per cubic meter. So what's the next step for the air quality modeling? So we start off with our experimental forecast, and we plan in the future to merge together with the Servier Mekong air quality explorer. So we just we're currently, I think, are writing the proposal for NASA Servier together with our partners also from Vietnam and Laos. And we're partnering with NCAR, and then we plan to use both the GEOS and the NCAR's WACCM for the background conditions, of course WRF-Chem, and we plan to use more like high resolution and with some data assimilation capabilities. So maybe to solve all those mismatch between observations and the forecast. And also a source attribution system wherein we can find out almost in real time where the pollutants come from. And then you can make some scenario, like if you reduce the transport, so this is what will happen with your PM 2.5 in the next days and so on. So basically we pattern with the system that's currently in place over India, which was also a project together with NCAR. And maybe Vanessa would like to say something more about this proposal or project.
That's all right. Thank you. Just that to add that decision support is important, I think, in the region, as we have seen from the presentations earlier, and a number of development has been going on. So we hope that air quality modeling will give the required information for not only for advanced warning for people to prepare in a few days in advance, but also for decision making or where or how to control the air pollution issues, which is, as we are aware of from this project, seeing from the monitoring data that it's the transboundary. So thank you very much.
Yeah, thank you. That's all.
Thank you very much, Ron. So the modeling is one part of the air quality management, and our project also have an activities after data collection to use the modeling. So any questions from the audience?
So I had one question.
Yes, please.
So I noticed, but I think the model performance looks really good, particularly on those days with fires. And I noticed that your the simulations actually was able to even show the kind of the plume. So is yours, the fire emissions, is it incorporated in pretty much real time into the modeling simulations?
Yeah, so NCAR has this near real-time fire emissions where you can like download the data. I think, for example, if you run the simulation today, so you'll get the fire emissions from yesterday, a bit 1 day delayed, of course. And then it will, so the assumption is these fire emissions, let's say yesterday, will persist for the next 3 days. So that's the assumption. Yeah. Mm-hmm.
That's pretty good, because otherwise, given the significance of that source, if that hadn't been there, then model performance would have been impacted. So it's really nice that you have that implemented there. So it looks really good.
So the near real-time fire emissions, yeah. So they're also based on the, I think, MODIS and various hotspots.
Yeah. And I'm hoping that the data from this network will be helpful, maybe for model evaluation, and maybe we can kind of start that as start discussing that as next steps.
Yeah, definitely.
And I think maybe you could use it without correction and then with correction, so we can try it both ways and see. But hopefully, with the amount of information that's there from this network as well as the Dust Boy network, both here in Thailand and Laos and Vietnam, you probably have a larger area where the bias, model evaluation can be performed. So yeah, we can discuss that as next steps.
Yeah.
Okay, Dr. Ron, there are one questions from the chat. They ask about which source of emission should be refined.
So yeah, I think for the anthropogenic, since we're using the Edgar HTAP, which I think was 2010, so that's quite outdated. So yeah, that's one thing we need to update. So if you have some updated emission inventories and would like to test it out, yeah, just let us know so we can test that out as well. And of course, especially for the northern part of Thailand and in the northern part of Indochina, where you have a lot of forests. So I think the biogenic emissions from forests are quite important to update as well. And I think Vanessa has been doing that for the past couple of years. So actually, we tried out the results, and it seemed improved the model performance, but we haven't implemented it yet here. Yeah. So I think, yeah, biogenic and the anthropogenic emissions, they have to be, I think, refined more.
Okay, thank you so much. Okay. So the next sections we gonna separate in the room, breakout room. So the audience can join the room by your own self, right? So I think for now, breakout room is already set, right?
Yes.
Yes.
I think you can go by yourself. You just click the breakout room. We set already by country, Thai, Laos, and Vietnam. So only the English language will be in the main room.
Yeah.
We can talk each other with English version in the main room. Plus you can.
Would we hear the discussion?
Yeah.
The translation is not going to be there, right? No translation for this one, correct? Because it's going to be both. I guess it wouldn't work between like a breakout room and the main session, maybe.
Yes.
That's fine. I was curious. Okay.
Okay, now we can go because today we will have a facilitator from Thailand group will be Ajahn Natipon, Dr. Natipon and me. And for Laos is Dr. Sisuwan. And for Vietnam is Dr. Hang, right?
Okay. I think we will spend around 1 hour
Yeah.
discussions, and after that we'll come back in the main room, and each country should be present some issue that we brainstormed together.
Yeah. And also if you would like to sign in and sign out break room, you have to do by yourself. We cannot do for you. So I think in the main room now, we have already some people here in the main room. Still have, okay, we can have take time to separate room now. I think some people in here still in the main room a lot. Please go to the breakout room now. Okay, just waiting. Okay, today is our aim of our workshop is very important for the future plan for our projects, so and our community also. So please give us the idea and what we're gonna do in the next future plan. Okay.
Hi, Ivan.
Hey, Prakash. Good
How
to
are
see
you?
I'm doing well. It's getting late over here in Western US.
Yeah, that's true. Thanks for joining. Would you be able to stay for that kind of the discussion after the breakout room, like in about an hour?
Yeah, absolutely. And it's been my pleasure. Really been enjoying these talks.
Okay, thank you. Yeah. Any thoughts that you had, like from the preliminary analysis that we showed? I know you are looking at some spatial aspects, right? In Washington State. Do you have like any thoughts on how else we might look at the data?
Yeah, I mean, along the lines of my question that I asked, we're pretty consistently applying the US EPA correction factor ourselves with our purple air sensors. And so I guess that was really my only thought was how does that preliminary analysis compare with what our EPA has shown? But it sounds like you're seeing a really similar result.
Yeah, we have not tried with EPA's correction factors yet, so that's probably the next step that we want to do. So are you seeing good improvement in performance after correction using that equation?
I should say we're not using the exact US EPA one. We're using it's very similar. It's called LRAPA.
Okay.
I don't know if you've seen that correction factor in the selection list, but it was developed by one of the regional air agencies in the Northwest US.
Okay.
And it's been shown to have slightly more accurate results for our region compared to the EPA factor, but it's very close.
I see. Okay. Now, but this is only for like online display, right? It wouldn't. Does it allow you to download data with the calibration already in there?
You're correct. Yeah, it's only for online display, which makes it challenging when you want to do, an analysis. But fortunately, they do show exactly how the correction factor is applied. So you can just incorporate that in Excel macro or something.
Okay. All right. Cool. Now you've been in this region before, so do you know the language, like either Lao or Thai?
It's been a few years since I've been to Lao, but that's primarily where I've been in the region. Okay. I'm trying to learn Thai as well, but it's very slow going.
Okay.
Yeah.
I might probably just go in one of those rooms. I won't understand anything, but I guess at least we can see the dynamics of the discussion. Yeah. Aisha, are you still here?
So the time is up. So sorry for tight section. Ajahn Tipawan didn't would like to say something, but maybe already here in the main room. You would like to say something, Ajahn Tipawan, continue the wait for another group?
Okay, maybe I want to acknowledge the Northern Thai Council สภาลมหายใจภาคเหนือ two names that if we can connect, that will be helpful for our low-cost sensor network overall in the upper northern Thailand. สภาลมหายใจภาคเหนือคุณวิทยาคองทรัพย์ค่ะ He is a key man of this council, and also คุณบรรณรสบัวคลี่ will be join us to help our from the university and to government office connected to the local council. That just briefly, yeah. Thank you.
Thank you so much for Ajahn Tipawan. So we already discussion all of the country that separated Thailand, Laos, and Vietnam, and also now we would like to have representative of each country to give briefly for the discussion in all of the idea that they give for us. So Hang, do you already to present it?
Yes, thank you.
Okay, from Vietnam first.
We have a very productive discussion, and yeah, Justin don't have enough time, but we have some concrete remarks, and Miss Nhung from Live and Learn will present on behalf of Vietnam team. Miss Nhung, please. Could you please share the information, share the slide, and then
yeah, thank you, Dr. Hung, for introducing me to the panel. Hello, everyone. My name is Nhung. I'm Citizen Science Program Coordinator at the Live and Learn for Environment and Community in Vietnam. And today we are pleasure to support the discussion session today from Vietnam, and we also have collected some ideas, some discussion from like many stakeholders in Vietnam. We focus on the stakeholder from the government, from the institute or university, and also some company like they are operating the local center network in Vietnam, and for the last 1 hour in discussion, we have collected some I think that very interesting idea, and I will present on behalf of the group discussion. And if you have any additional ideas or additional discussion from Vietnam, please feel free to unmute yourself and add. Let me share the. For the last 1 hour, very concise discussion, we focus on 3 questions that specifically requested by the organization. And the first one, that what is the air quality challenge that you are trying to address it in Vietnam? We have 2 opinions from the government agency. First one is from the Northern Center for Environmental Monitoring, and the second one is from one of the province. So here we have from the Hanoi EPA, the ministry, that they want to for the air quality challenge in Vietnam. They said that they want to expand the AQ, the air quality monitoring network, and enhance the QA/QC and data quality for emission control. And for at the provincial level, they want to have reliable data to convince the city with a suitable measure on improve the AQ, the air quality in Vietnam. So you can see that from the government agency, they have a kind of they have one the challenge in improve the air quality, and they want to have a more accurate data that they can propose the measure and the emission control. And from the university or the experts group, they want to have more data to to do more research and to know more about the trend of the PM2.5 of other air pollutants in the country. And then they think that if we have many data from many local sensor network and many models and the data from the air quality monitoring in at the government national level, they can have more research and more findings on the air quality situation in Vietnam. And from the NGO Live and Learn, we want to we think that the air quality challenge in Vietnam is how to communicate with the citizens, with the people about the air quality situation, and how and let them know that how to protect themselves. And maybe in Vietnam, we think that if we have more data in air quality, it can support the province to develop their air quality management plan at provincial level, the law on environmental protection that just new released in Vietnam, that they they force the provinces to do this. That is the discussion for the first question. And the second focus question that we focused on, that it was what is your objective related to air quality improvement, and what is the goal for air quality improvement? Like, because in our group we don't have like representative from the government directly joining in, and we think that this question is more appropriate for the government agency because they will know more about how to, like, what is the target for PM2.5 or other air quality pollutants. But we think that right now the national standard of Vietnam for PM2.5 is like the same, similar to the Thailand, and for the last like about 10 years, the PM2.5 concentration in Vietnam at the annual average is quite higher than the national standard that of 25 microgram per cubic meter. And we think that for now we should like focus more how to control the emission, how to do like to reduce the annual average concentration due to that level. More focus, more measure, more investment, more effort into that before we adjust our national standards. And for Dr. Thao from Thailand also think that like we should, like in the long term, we should have like a pathway. We have more like a longer target, longer term target that follow the WHO target that they just like adjusted their recommendation for PM2.5 and other air pollutants last year. Maybe we should lean on that. We can like develop our pathway that to reduce the health impact of air pollution. Yeah. And for the third question that we focus on is what do you want to get out of this data, like from the AQC network? And here we have opinion from the government agency that they want to have raw data, and they also and we discussed a lot of like what kind of information from those networks should be shared with other stakeholders. And we think that the first one is the data, the raw data for sure, and the second one is about the QA/QC procedure that is low cost sensor, especially the purple air, the dashboard that run by the AQC project have done in the in their network. That because the QA/QC information is very important, that the government agency and the researcher and even for like other stakeholders that using that data from the local sensor can like evaluate the quality of the data, so they can apply these data into kind of like for the fit purpose, that it should be serve the right purpose of the data. It's not, maybe it's not like for regulatory monitoring, or they cannot, like for now they cannot reach the supplement data monitoring, but they can still like serve some other kind of purpose, such as the research or communicate with the community or the citizen about air quality at the time. And we also want to like propose one kind of like mechanism about the cross platforms, that in Vietnam we have a like variety of local sensor networks, and in the upcoming time we also that from the Vietnam National University, they also have developed a website that will like show the daily PM2.5 concentration from modeling and satellite data. And we think that if we have a lot of kind of resource, so should there any kind of mechanism between those projects, between those like stakeholders, that we can share all the data into one platform and with many layers of the PM of the air pollutants, so people can have more data, people can have more like understanding what is the air quality situation now, and they can see that they have many methods of air quality tracking. And I think that it's a very interesting idea that, especially for Vietnam, like we have a lot of like networks, we have a lot of like current ongoing projects that also working on the air quality and produce the PM2.5 concentration right now. And one thing we also care about the calibration of the local sensor, and we want to like propose like there should be more programs or more mechanism from the government that to allow the local sensor network to put their device next to the reference instrument to help them like improve their data quality and to more kind of like purpose for the data deprived from the local sensor network. So that's all our discussion very briefly from for the last 1 hour. And if my colleague in Vietnam, you have more like additional discussion or exchange here, please like unmute yourself and we can directly discuss with each other. Thank you.
Okay, thank you from Vietnam. So very nice talking and very nice discussion. So maybe the audience would like to say something or class?
I think we can probably have a broader discussion after we hear from all 3 countries.
Okay.
But very briefly, I think, I really liked all the points that they had discussed and mentioned. And, I think we would really love to have this data be part of any platform and even maybe work with the government and seeing how we can calibrate the sensor data. And I think right now we don't have a way to co-locate the sensor next to a reference monitor there in Vietnam. So if we are able to do it, then we can develop calibration factors specifically for Vietnam. And yeah, that's something that we are very much happy to discuss further, as part of this project. But yeah, thank you.
Okay.
Yeah. I have like small discussion that for in Vietnam, if you want to do the calibration, you can contact with the US embassy or the US consulate in Hanoi and in Ho Chi Minh City. That because last year Live Alone and IMES also conducted a calibration program. Like we do like not directly with the bank in the US embassy, but we put a reference instrument there in like for about like 6 to 5 or 6 months, and then we can like calibrate like it's not directly, but it's still like through a reference monitoring instrument. So in Vietnam, we suggest you can contact those the embassy, the US embassy.
Okay, yeah, thank you. I think we did. The issue is because this instrument uses wireless internet. There were some security concerns that was not allowed. Did your sensor use Wi-Fi or was it SD card?
We use a card. Yeah.
We use card. Yeah. So that's the difference, I think, because this one uses wireless internet. Security restrictions prevented from, I guess, from being able to use it there. So yeah, so that wasn't possible.
Yeah.
Thanks for the suggestion. So if anyone else, if you know of any even research universities or anyone who has a reference monitor, then we could probably co-locate it there, or maybe if you could put us in touch with government, we can also talk to them. Thank you.
Okay, so for Vietnam is already presented. Okay, move to another country is Laos. I already turn on it. So do you hear me?
Yes, from Laos, Ms. I will representative from Laos will give some light about discussion.
Good morning. Okay, I'm Wasna from Laos. I will sum up the thing that we discussed in our group. Actually, I would like to say that in the Laos group, we don't have too much participated. So and the most of the participated just from faculty from university. We don't have many people like from some May area. Yeah, as we did discuss on the team, just like
คุณศรีสุวรรณคะ Hello, can you hear me?
Yes.
Yes. So for now we I think they have some problem with the Lao presenter.
I will check with the Vasana again. So I think that representative from Thailand can leave summarize after that. When I can contact to Vasana and return to Laos.
Ajahn Wan, are you ready?
Actually, I didn't finish the summary yet, but it is talk. It's okay. So and here I would like to share my screen. Okay, for Thailand is briefly to summarize. Actually, we have many people to give us the discussion about the application of AQC. I think the first question is, what is the air quality challenge the typing to address? We have the representative from the Mae Hong Son councils. They say about the local communication is very important to doing in many sections. And they have many activity to do in this year. Also, they have to understand the community understanding because it's very difficult to give them the message and give them the about the air quality for the community because they have many habitat. Because the mainly of the Mae Hong Son province is the hill type, so I think they said like depend on the community that understanding, but for the air quality challenging, and this year is quite good, right?
Yes. So apart from local communications, they actually mentions about the communicate between people and governments, and also another part that contribute with the air quality management. And they said communication is the heart to solve these problems. So the one thing that they mentioned is local communications. And another issue that they mentioned is about the powers of government. According to the unique types of geography, they have several unique types. I mean, like living pathway, right? They're quite unique. And they said that the peoples in community should manage these problems by their own self, by their own way. It might be suit for their life more than use only single policy to solve this problem all of the area. Okay. And the last issue, they mentions about the data management. Actually, in northern Thailand, we have a lot of sensors that were set for long time, and the data did not transfer to the government or to the person who have the power to manage this issue. So that's why data management is the one issue that quite challenge for us.
Yeah, they have another province also, not only Mae Hong Son, and Phrae is also give us about the community for, because it's this year they have many activity about air quality monitoring, such as they have another low cost sensor in, we call shortly that Ajahn Tipawan said is NT. And also they have a dashboard and also as AQC, but the data from local community that didn't use not very well in terms of data management. So, and they have Dr. Swang, he said like a NTAQ HI now online in 180 station for the low cost station in 9 province in upper northern of Thailand. So we can apply for all of the low cost sensor to work together. And also from NAN is the NAN Council is the news. Yeah, this is the new web page for เครือข่ายรักอากาศน่าน This is one page that they would like to give us to communicate with the air quality management. So, and next question, this is we show that we have already 20 of AQC that work in upper northern of Thailand. And also the next question is, what is your objective related to air quality improvement? I think we catch up many they're doing in terms of the improvement. They have activity like Mae Hong Son province that they says the government they move such as the I mean the in the center of the province they move to local management for air quality management for improve the air quality, that in terms of the municipality and also in terms of the health section. So if we can doing in terms of our knowledge or our data support for them is quite very good for them, because we are the academic part to give them the data for them to manage the air quality improvement. Yeah, right now. And maybe if Ajahn Vanisa, Ajahn Tipawan, and Ajahn Somporn, if you catch some point, you can say something in our main group. This is yeah.
I think it's quite well covered. Just that I have a very good impression regarding the sharing from all these, mostly from Northern Thailand, Breath Council, and they would like to integrate the data and make it easy for the public to understand about air quality. I think that's the point that I got. Mainly also, yeah. So maybe if we can have local workshops to disseminate more and people can understand more in an easier way, and also related more to how they could act. Yeah. Thank you.
Thank you, Ajahn Vanisa. Yeah, it's the main point there, because we run all of our local sensor or our AQC network from the northern breath councils. So it's very important sector for us to doing for this program. So Ajahn Somporn, you would like to say something about
Yes,
it?
thank you. So I also appreciate the sharing of the local people who joined the workshop today in our group, because I think that they are very interested in our data and also willing to have more data in the future. They also ask for the academic knowledge to share with them, so then they can understand better what the source of the pollution and the health impacts and so on. So I think it's very useful for both sides. Yeah.
Okay. Okay, go to the next question. What types of data are available and what the new data are need to support the objective? How can AQC network data to help? This all of our group Thailand, we have many network now. I think a summary of that. The main we doing, we have also NT network from the Chiang Mai University that the head of this is Dr. Tipawan Prahamonton. She doing very well this year to put the low-cost sensor and also dashboard network and work with us AQC network for the upper northern of Thailand. I think all of three kind of main low-cost sensor network can be work together and support them to doing. The mainly is how they use it and how communicate it in terms of local communication. Dr. Sawang, he suggests us they have the one community to communicate with the community every day by line group, line, or so says every day what happened with the air quality in terms of the area every day. They said like us, we doing with the breeze council in northern of Thailand every day. We put it 4 times, 8 o'clock in the morning, 11 o'clock in the 11 o'clock, and 2 p.m. and 7 p.m. We give them in the briefly in terms of the northern of Thailand. So if they have something wrong, something like today, the air quality high in this day because the rate level of the air quality index in terms of US index. So we just put the data for them and set and give them only short message like be careful, the now is the PM2.5 is increased in terms of this period, something like that. Yeah, this kind will be work together in terms of low cost sensor in this area. Yes. Okay. Next. Okay. What are other applications that the AQC data can be used for support your objective? Yeah, this one is good for use because it's AQC or purple air. Because purple air is main, they have many kind of data. So should be doing what we will give them. Like Ajahn Somporn said, we have to have our part in academic part, also the research part, to give them like from the Mae Hong Son Breathe Councils. They give us, they would like to have the data from us to support them to improve air quality management and also in plan. Yeah, if we have opportunity to meet them and also in Nan also, right? Okay, maybe some of you would like to give or add me for support this question. Okay, move to last year. what type of invention are thinking about the improving the air quality, and how often do you need to track, and how can this AQC network data to be helpful? I think we say already what happened with discussion. Okay, I think mainly in terms of Thai people or in terms of Thai participant in here, you would like to add more, because we have the time for say, or for catch up, because as I writing in terms of the Thai, and I will give all the data for in this area, because it's here. It's done already. Or okay, I think Laos, are you already joined? Lao, Mr. Sansuan.
Yes, I'm coming back.
Okay.
Okay, on behalf of Dr. Siswan, I will sum up the thing that we discussed in Lao group. Yeah, for the participant from Lao, is not from multiple parts, just from academic part and a few people from ministry. So we have consulted each other about the strength and the weakness, and also the future installation plan. For the strength of this equipment, is quite good and very, very useful to help us to able to monitor air quality, which help to plan for the effective control. And also the data and the data that we get from that is very useful for our research work. Yeah. But by the way, the equipment still have some weakness, like some country also discuss about that is need to use like Wi-Fi or how to say a Wi-Fi or some SIM card or something, yeah, to like a network, yeah, to operate it. But it's quite hard to install in some part in Laos, especially in the rural area. And also it's hard for the operation. Like if we set up that equipment in some part, like in rural area or something, it's hard to maintenance. It's hard to operation. Yeah. And somehow, like some part that we think that is really, it's quite good to, it's very useful to set up that equipment, but as the some as the something like a network or electricity is not efficiency over there. Yeah. And also we discuss and we talking about the future installation plan, like something like some place like a landfill, because in Laos, in landfill they also have some activity like burned and burn the garbage, and also the some northern part of Laos that they still do some like a burn, create the land for the agriculture. Yeah. Yes. Yeah. That is all about we discussed in our room.
Okay, thank you so much from Laos. I think now already 3 countries to do the discussion and all of data. So now we welcome for the suggestion or the question. Welcome to ask all of 3 countries. So maybe start with Prakash.
Yeah, Juan, thank you very much. Thanks for all the representatives for presenting the suggestions, the discussion. So if I were to kind of based on my notes here, and I think we will kind of go back, look at the recording and take again detailed notes later. But based on my quick notes here, it looks like there are some common themes between the countries. Obviously, there is definitely the need for data across all 3 countries, right? I think Vietnam mentioned about wanting to expand air quality network, the need for data. And I think Laos also said that. I think Thai group also mentioned about maybe not need for data that is understandable. So there's definitely need for data, but combined with communication, right? How can we communicate with citizens on air quality? And I think that was brought up both by Vietnam as well as the Thai group. So that seems to be a common thing. So I think the main thing then, it looks like one of the things that we could focus on that would be helpful is coming up with communication strategies on how to interpret the data from the sensors, what can be applied, what it can be used for. So I think that is a very good suggestion. I think that could be one of the educational materials that we were thinking of. We are thinking of developing a few educational materials that would be helpful for stakeholders. And I think this feedback is actually very relevant. So that could be one of the areas for educational material development, is the communication strategy. I'm going to make a note of that for myself. Of sensor data and what it means. Because I think that is something that's definitely common across both countries here, and I think that would also be useful for Laos as well. So that could be a good activity for educational material. The other common aspect that I see is the QA/QC that was mentioned primarily by Vietnam and by Laos. Yeah, I think that is, I think for Thailand, we have the co-location, so we can definitely develop the correction factors. What we could, I think we can, we will be applying those correction factors for other regions as well, but I think we'll need to come up with a way to see if there's any specific ways of doing this evaluation in those countries. So that is something that maybe we can work on. Regardless, I think it also depends on how we want to use this data, right? I think Vietnam acknowledged that this is not going to be used for regulatory purposes. It's not even for supplemental monitoring. And I think that's the case here in the US as well, right? We heard from speakers yesterday that it is not being used for regulatory purposes. But these sensors do have their own application. So we'll have to kind of, it's a balance between how accurate we can get and what we can use it for. But given that much of the interest here has been on communication and maybe communicating to the public, I think that the level of corrections that we could probably get from these calibrations might still be relevant. So I think that is something that we can still continue to explore in terms of the calibration. And this is something, like I said, I think if we can work together with the government and maybe co-locate the sensor, I think that would actually be a good way to make sure that the data from this is even more accurate. Because it really needs very region-specific calibration that is really important. So I think we will still try that, and then hopefully we can, find ways to collaborate. So I think those were kind of the main things that I could glean from this discussion. It appears Vietnam government is very much interested in making sure that the data is of good quality and making sure that there is, it's being used for the right purpose. And I think that's I can very well understand the reasoning behind that. I think it's important to definitely make sure that the data is not being misused, and more so, the data does not cause undue fear in the public. So I can understand where the government is coming from, but I think that probably also ties with the communication strategy. So if we can educate the public and the communities on how to interpret this data, how to use this data, and and what does it really mean if it shows really high value, then I think that's where hopefully the citizens will also begin to understand the usefulness of the data, and that's where and then maybe it might help more in the public and government collaboration and participation. So those were kind of some of the comments that or based on kind of the feedback from the different groups, it seems like those are relevant activities that we could take. And I think one of the things I like the point that was made by the Thailand team about integrating the data from multiple sensors, and that is actually that's also very good. I think what we really want to do is obviously come up with not repeat what others have done, but rather see if we can come up with a uniform something that will complement others, and so that is actually a very good thing, that if we can collaborate with others and do that. So and Thailand has so many sensors that the spatial resolution that you can get out of that is quite high. If we can ensure that the data from all these sensors can be converted to a uniform basis, right? I think that is the main thing that we will need to look at when trying to bring together different networks, is trying to make sure that the data is on the same basis, because each sensor may have like a different level of performance. So that is, I think that's a good, we can definitely, collaborate with the other teams and see how we can make this data useful for everyone. Is Ivan still on the line? Mr. Ivan Bing from the US?
Yeah, I'm still here, Prakash.
Okay. Would you, sorry to put you on the spot, but I wanted to see if, as a representative of a local government agency in the US, and you are exploring both sensors as well as regulatory monitors. Can you share a little bit on the perspective that your agency is looking at, looking the sensor, the perspective that you're looking at it from, and how you are currently using it, and perhaps where you see it going in the future?
Yeah, sure. So just as others have said, we kind of use them for informational monitoring, not regulatory purposes. So some of the best applications are locations where we don't, where we haven't previously monitored before, or areas that are really difficult to locate monitors in. So really mountainous areas, or areas that are quite far from cities, but they provide very valuable information during specific times of the year, like wildfire season, which is becoming really common in the Western US. But we don't use them for regulatory purposes, and we always make sure to inform our data users that it's really important to apply those correction factors before they do any sort of interpretation of the data. And more frequently, the citizens are becoming aware of that because sometimes data from the purple air sensors in particular can overestimate the actual PM2.5 concentrations by as much as a factor of 2. So it's really important that we communicate to citizens that while extremely useful, these sensors are not quite on the same level of quality or accuracy as our much more expensive traditional monitors.
So thank you very much, and I think you brought up a very good point that that hopefully that probably also addresses some of the challenges that others mentioned about communication. Can you share a little bit about how you like what strategies you followed to communicate to the public? Was there backlash initially, or were there a lot of concerns initially from the citizens, and then has it over time gone down? Do you see the public understanding how to interpret this data?
Yeah, there is a bit of distrust among certain individuals that the values that they're seeing on their purple air or low cost sensors, they're quite a bit higher if you don't apply the correction factor. And some people distrust the government monitoring agencies, and they just come to the conclusion that we are keeping the actual values from them. So they want to believe that the data are actually higher. But we have had success in social media campaigns in terms of educating folks on application of that. With the Purple Air site, you can apply the correction factor and the URL will change for the map. And so if you copy that URL and share that with your users, they can bookmark that URL, and it will automatically apply the correction factor when they go back and check data on the map. So it's been really useful to combine those two strategies and share the corrected URL with them.
That is that's a good suggestion. I didn't realize that it actually generates a new URL that is, I guess, that one can bookmark and then go directly to the calibrated value. That is actually very helpful.
Yeah,
very powerful, in fact. Yeah.
And similarly, you can, depending on where you zoom on the map, the URL will change as well. So if you want to just zoom to a small section of the world or of a jurisdiction, maybe of a country, and you also change the correction factor, it will create a unique URL that you can just bookmark and share.
Okay. Okay. All right. Thank you. Thanks, everyone. I know, so from a US government perspective, from a local agency perspective, Mr. Ivan Banks shared his perspectives on like what their agency is using this sensor for, and I think also the communication strategies that they have used. and I guess over time they have found success in helping the people understand what's right and what's not right. What do is there any feedback or anything from any of the community members or any of the stakeholders on the thoughts shared by Mr. Bing or anything that the other countries had shared?
Okay, Ajahn, Dr. Vanessa.
Thank you. Just that I really appreciate that, you know, like hearing that from the US have this way of, you know, raising this community awareness with these low cost sensors and the approach. I just want to share a little bit that right now, actually, there is the other activity ongoing that has not been mentioned, but it's running in parallel to the workshop, is that what we call the ACUT workshop, supported actually. Can I share screen just for the picture? We have this equality awareness raising under American-Thai collaboration as well. And this is just the ongoing project supported by the US Embassy funding. Just to go quickly, that the workshop is running this week for the first time. And we will have more. And this also about low-cost sensors. Making by lay people. Like for this one, because we have actually, just to go quickly into this first one, is that there's American corners across in a few provinces in Thailand. So the idea is to empowering people to learn about equality, and so that we like this one in the north, in the northeast, and in the southern Thailand. So we focus on technology transfer for the undergraduates. And Chiang Mai University is one place that we have the American Corner, and the workshop is running actually until tomorrow. So the idea is just to have DIY, the air quality monitoring sensor, to so they learn how it works in the workshop. You know, just by have the hands-on making their own, and also they can do the assessment and see as the output that we want the university undergrad and lecturers who can join in this project as well. And they know how the air monitor and awareness can be raised. So yeah, just briefly to talk about it. So it's running in this year, just support by the US Embassy. Thank you.
Thank you so much for Dr. Vanessa. Okay, for the audience, you would like, because it's, I think, Plakas, maybe we have already the end of the workshop. Maybe you, I would like to some comment all of the workshop that we going to be doing already 3 days. Already the first day, we give some the knowledge about our network and our projects. And the second day, we talking about the air quality monitoring. So today we have a discussion part for all of our 3 countries. So maybe here, the audience who join all the workshop, can you say something, or you can suggest us to doing in the future plan? Ajahn Somporn, you would like, because you are the host of Thailand, maybe you would like to say something for our workshop today for 3 days.
Sure, thank you, Juan. Yeah, as I said, I really appreciate for the audience who join us. Even the workshop is quite long. I mean, 3 days. Yeah, so I would like to thank everyone for joining our first workshop, and special thanks to our stakeholders to share many ideas with us. I think they are very useful information that we can use to improve our project. I believe that we already built up the network among at least 3 countries, Thailand, Laos, and Vietnam. And this will become a stronger network in the future. I also think about the speakers who we invited to present their data concerning the air quality monitoring and management from 3 countries and also from the US. I think we can cooperate again in the future. And I really thanks to all of them. And I think it's very useful, not even only for us, but also for everyone who joined. Yeah. That is my first thought. Yeah.
Okay, thank you from the message from Ajahn Sumpon. So the next, I think I would like to give the opportunity for saying Hong from Vietnam. Would you like to say something?
Yeah, thank you all for very nice to organize the workshop. Our please to keep in touch with the air quality community for a better environment in the Southeast Asia. Thank you, Chiang Mai University team. You did a very good job for carry out the workshop. Thank you.
Okay, thank you, Hong. And from, okay, Prakash.
Sure. Do we have Susma? Maybe you can also ask him before I give my final comments from Laos.
Yeah. Okay, from Laos.
Suwan
is here. Maybe some of you from Laos. I think.
Okay, if not, that's fine.
Okay.
Yeah. Yeah, I think I really enjoyed meeting all of you, and I wish this had been an in-person meeting, but given the situation, I think we had to go virtual. Regardless, I'm really happy to have been part of this workshop over the past 3 days, and for staying with us until day 3. We've had a really good attendance, so really thank you very much for being part of this event, for attending the workshop, and for sharing your thoughts. I think we have some useful path forward in terms of the the educational materials that would be useful for stakeholders, and so we'll be working on that. So I think, like my colleagues mentioned, really thanks to the entire CMU team, Chiang Mai University team, for the organization and execution of this workshop. Really very well done. And then thanks to all the collaborators from CMU, NARET, Center for Environmental Monitoring and Modeling, CMM, and National University of Laos for being part of this organization team, and working together as a team to put together the agenda, identifying invitees and speakers. I know it's been a big lift, but thanks to all of you. I think we've had a very good discussion over the past 3 days. And so really thanks to everyone for making this happen. And I think Vaughn just shared the feedback. Please do complete that. I think it's consider it as like, what did you really learn from this? I think that's what we really want to understand. Hopefully, there were some aspects that you learned new, and some aspects which you already know. So please do provide your feedback. And lastly, I think like Dr. Sampon mentioned, this is the start of this network, right? This is our first workshop. And what we would really like to do is be in touch with all of you as part of this community, and get some constant feedback. And we will be sharing information that we generate out of this project and through maybe webinars, or we do plan to have one more workshop sometime next year. So we want this data to be useful for you, and we are going to try to work on this educational materials and communication strategy and the calibration within the resources that we have to make it as helpful as we can for all of you. And we really hope that this data will help in perhaps mitigating air quality, air pollution in the future. So thanks everyone, and back to you, Mon.
Okay, thank you everyone, and don't forget it to evaluate the form that I sent you in the chat, and also here the QR code, because it's very that Prakash said we would like to know for your site. You can write anything in the comment after the evaluation. We have the last question that you can put it, so we can make better in the future. Also, like Prakash says, we will have the next section on the next future plan to doing about the workshop again. So maybe you can put the comment and everything that you would like to say for us. And for behalf of CMU, for the host for workshop, I really thank you, all of you, Prakash from US past, and for the head of the project, and for CMU, Nalis, and from Vietnam, from Laos, and all of participants for today or for 3 days. I really appreciate this program, and see you next time, I hope.
Thank you very much.
Yeah, thank you very much. And don't forget, yes, and don't forget to evaluate for us.
Thank you.
Yeah.
Thank you very much.
Thank you. Bye bye.
Bye everyone.
Thank you. Bye bye.
สวัสดีครับ
สวัสดีครับ
สวัสดีครับ บ๊ายบาย
Bye bye.
Forget
Bye bye.
Bye, everyone.
Bye bye.
Because you can stay in this room.
Okay.
I
So
don't know,
organizer
if you
can
have free
we
time, you
stay